year ago, I had one of the most frustrating experiences of my career. A customer brought in a 2020 Toyota Camry with only 35,000 miles. The fuel injectors were completely clogged. The intake valves had heavy carbon buildup. The engine was running rough, misfiring, and the check engine light was on. This car should have been in perfect condition at 35,000 miles. When I asked the owner about her fueling habits, the answer explained everything. She always filled up at the cheapest gas station near her house. She routinely ran the tank down to the warning light before refueling. She once accidentally put E15 gasoline in the car, and she had never once used a fuel system cleaner. Every single one of these habits had contributed to the damage. The repair cost was $1,800, and the worst part is that every penny of it was completely preventable. I see this pattern over and over in my shop. Owners of Toyota, Honda, Lexus, and Subaru vehicles who take perfect care of their oil changes and tire rotations, but completely ignore how they fuel their cars. Your fueling habits affect your engine just as much as your oil change schedule. In some cases, even more. I have been working on Japanese cars for 19 years, and these are the 5 gas station habits that I see silently destroying engines every single day. Habit number 1. Running the tank below a quarter. This is the most common destructive fueling habit, and almost every driver does it. Here is what happens inside your fuel tank when the level drops below a quarter. Your fuel pump is submerged in gasoline at the bottom of the tank. The gasoline acts as a coolant for the pump motor. When the fuel level drops too low, the pump is partially exposed to air. It overheats. The electric motor inside the pump wears faster. Over years of consistently running the tank low, the pump degrades prematurely. But that is not the worst part. Over the life of your car, sediment, rust particles, and moisture accumulate at the very bottom of the fuel tank. When the tank is full, the fuel pickup draws from well above the sediment layer. When the tank is nearly empty, the pickup draws from closer to the bottom, pulling in concentrated contaminants. These particles pass through the fuel filter and eventually reach the injectors. On modern direct injection engines used in most Toyota, Honda, and Subaru models built after 2012, the fuel injectors operate at pressures of 2,000 to 3,000 psi. The spray holes are microscopic. Even tiny particles can partially block these holes, causing uneven spray patterns that lead to incomplete combustion, carbon buildup, and reduced efficiency. The fix is simple. Never let your tank drop below a quarter full. Treat a quarter tank as your new empty. This keeps the fuel pump submerged and cooled at all times and keeps the fuel pickup well above the sediment layer. Habit number 2. Fueling at no-name discount stations. Not all gasoline is created equal, and the difference matters far more than most people realize. In the United States, all gasoline starts at the same refinery, but what happens after the refinery is what separates good gas from bad gas. Major brands like Shell, Chevron, BP, ExxonMobil, and Costco add a specific package of detergent additives to their fuel. These additives are designed to clean fuel injectors and intake valves as you drive. They prevent carbon deposits from forming in the first place. The standard is called top-tier gasoline. Top-tier fuel contains 2 to 3 times more detergent additives than the EPA minimum requirement. No-name discount stations meet the minimum EPA additive requirement, but nothing more. Over time, the difference is dramatic. I have pulled intake manifolds from 2 identical Toyota Camrys with similar mileage. One used top-tier gas exclusively. The other used whatever was cheapest. The difference was visible immediately. The cheap gas engine had thick carbon deposits coating the intake valves and ports. The top-tier engine looked nearly clean. The price difference between top-tier gas and discount gas is typically 5 to 15 cents per gallon. On a 15-gallon fill-up, that is 75 cents to $2 and 25 cents more. Over 50,000 miles, you might spend $200 to $400 more on top-tier fuel. A single fuel injector cleaning service costs $150 to $300. Carbon buildup removal on direct injection engines costs $400 to $800. You are saving $200 on cheap gas and spending $500 to $100 on repairs. Habit number 3. Topping off after the pump clicks. When you are filling up and the pump nozzle clicks off automatically, that is not a suggestion. It is a precise shutoff, triggered by a sensor detecting that the tank is full. When you squeeze in a few more cents worth of gas after the click, you are overfilling the tank. This creates several problems. First, the extra fuel floods the evaporative emission system. This system collects fuel vapors from the tank and routes them back to the engine to be burned. When liquid fuel enters this vapor system, it saturates the charcoal canister. The canister is designed to absorb vapors, not liquid. Once saturated, it can no longer function properly. The car triggers a check engine light with an EVAP system code. Second, the excess fuel can damage the purge valve and vent solenoid. These are electrical components that control vapor flow. When they fail, replacement costs $100 to $300 plus a diagnostic fee. Third, modern fuel tanks have an expansion space at the top. This space allows the fuel to expand when it heats up. If you fill this space with extra fuel, the expanding gas has nowhere to go. It forces its way through seals and connections, potentially creating leaks. When the pump clicks off, stop pumping. Do not round up to the nearest dollar. Do not try to squeeze in an extra half gallon. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. Habit number 4. Using E15 in a non-certified engine. This is a mistake that is becoming more common as E15 gasoline spreads to more gas stations across America. E15 contains 15% ethanol by volume. Standard E10 contains 10%. That extra 5% sounds insignificant, but for many Japanese engines it creates real problems. Ethanol is hygroscopic, meaning it absorbs moisture from the air. Higher ethanol concentrations absorb more moisture. This moisture can cause internal corrosion in fuel system components. Ethanol is also a solvent. At higher concentrations, it can attack certain rubber and plastic components in the fuel system. Fuel line seals, injector O-rings, and fuel pump diaphragms designed for E10 may degrade faster with E15 exposure. Most importantly, ethanol burns hotter than gasoline. Engines calibrated for E10 may run lean with E15, causing higher combustion temperatures. Over time, this can damage exhaust valves and catalytic converters. Check your owner's manual. Most Toyota, Honda, and Subaru models built before 2019 are certified for E10 only. Using E15 in these vehicles may void engine-related warranty claims. If your car is certified for E15, go ahead and use it. If it is not, stick with standard E10. The few cents you save per gallon are not worth the risk. Habit number 5. Never using a fuel system cleaner. Modern direct injection engines have a specific weakness that older engines did not have. On a port-injected engine, gasoline sprays onto the intake valves, constantly cleaning them. On a direct injection engine, the fuel sprays directly into the combustion chamber, bypassing the intake valves entirely. This means nothing cleans the intake valves. Over time, oil vapors from the PCV system coat the intake valves with carbon deposits. These deposits restrict airflow, cause misfires, and reduce performance. Japanese engineers know about this problem. That is why Honda designed the Civic and Accord with dual injection, both direct and port injection. Toyota added port injection to its turbocharged engines for the same reason, but many Japanese engines still use direct injection only. For these engines, using a quality fuel system cleaner every 5,000 miles makes a measurable difference. Add a bottle of Chevron Techron or Gumout fuel system cleaner to a full tank of gas. The detergents in these products reach the intake valves through the combustion process and slowly dissolve carbon deposits. Cost is about $8 to $12 per treatment. Once a year, use a dedicated intake valve cleaner like CRC GDI intake valve cleaner. This is sprayed directly into the intake with the engine running. It dissolves the heavy carbon deposits that fuel additives cannot reach. Total annual cost for fuel system cleaning is about $60 to $80. That is the cheapest insurance policy you can buy for a direct injection engine. The numbers do not lie. Let me put the total cost of bad fueling habits into perspective for a typical car owner over 100,000 miles. Fuel pump replacement from running the tank low, $500 to $900. Fuel injector cleaning from cheap gas, $150 to $300. Carbon buildup removal from no fuel treatment, $400 to $800. EVAP system repair from topping off, $100 to $300. Fuel system component damage from E15, $200 to $500. That is a potential total of $1,350 to $2,800 in completely preventable repairs. The cost of doing it right? Use top-tier gas. Extra cost, $200 to $400 per 100,000 miles. Fuel system cleaner treatments, $120 to $160. Never letting the tank drop below a quarter, $0. Never topping off after the click, $0. Using the correct ethanol blend, $0. Total cost of proper fueling habits, $320 to $560 over 100,000 miles. You spend $400 to prevent $2,000 in damage. That is a 5-to-1 return on a very simple investment. Japanese engineers built these engines to last. Your fueling habits determine whether they will. If you found these tips helpful, be sure to watch this next video as I am sharing insider tips to help you cut repair costs and keep your car running like new.